welcome back everyone. So today we're obviously going to be straying off linear algebra again. I'm not planning on making this channel, on focusing this channel completely on, linear algebra, those forms of concepts. I like doing some fun videos from time to time, and today we're going to be, integrating, integrating ln x cubed by parts, for fun. It's going to be tedious, yes, but it's going to be fun. So let's get started. And we're going to be obviously using the integration by parts formula, which is the integral of u dv, the differential of v is equal to uv minus the integral of v du. Basic stuff if you do linear algebra. But anyway, I just enjoy integrating sometimes. So obviously we're integrating by parts, so let's get our u's and v's and dv's and v's and du's. So let's set u equal to, we're going to set u equal to ln x cubed, right? And that makes du of u, du. We can just easily use the chain rule to solve this. First, you work on the outside and think this is just a constant here, or some value here. You don't have to worry about this. So you can first say that it's just. Whoops! I meant to write a 3 there. 3 times ln x squared, and then times 1 over x, because then we're integrating that section there. So that's du. Pretty basic. And then what you want to do is you want to find your v and dv. So I like finding dv first, because that's the obvious one. It might not be obvious at first, but it's obviously just going to be 1. It's just going to be equals dx or equals 1 dx, because there's a secret 1 there, times 1. So we can write the 1 there. And then v is just equal to, well, we're integrating here, and the integral of 1 dx, everyone knows that it's just x. So v is equal to x. And that makes sense, because if you divide, it's just common sense, right? Integrating 1 is always going to be x. It just makes sense. Or alternatively, the derivative of x will be 1. So that's another way of thinking about it, obviously, since the integral undoes the derivative. Okay, so next step. This is just going to be part 1, since this is going to be decently long series, and I want to go through this slowly. So now we can actually start plugging into the formula. So, oops, let's use a different color. I want to start playing around with different colors for this. So we can use blue. Well, let's use black. The integral of u, which is just, we'll color code actually. This is equivalent to this, by the way. I mean, this is let me show you, because I have to remember that you can't see my hand. So this is equivalent to this. Hopefully you saw that. So, and then dx equals u times v. So, oops, that was interesting. Yeah, you see how this is going to take some time. Yeah, times v, so that's just times v, which is x. And then minus the integral of v du, x du. So actually x times 1 over x, so this can cancel. We can instantly cancel terms here. So we'll just instantly erase that, so we don't have to worry about v anymore, nor we don't have to worry about the 1 over x. So we just write 3, did it again, 3 ln x squared. And we can just take the constant out, right? So we get, so that's equal to ln squared cubed x times x minus 3 times the integral of ln x squared dx. Sorry, I forgot to put the differential here. Okay, well, obviously now we have to integrate ln squared x. So to do that, we actually have to first, again, following the pattern, we're also gonna have to differentiate ln just regular ln x, or the natural log of x, which is just log sub e of x, if you wanted to know. So we're just gonna cut that off for now, and make sure to return to this in a second. I'm gonna circle that. Just remember, I'm gonna put ln cubed x. Okay, so that's, so we can just put that aside for now. And here we're gonna do the integral of ln squared x dx. And I'm going to leave that on a cliffhanger for now. And in the next video, we're going to work on this. And in the following video, unless I make that a long one, we'll then differentiate ln x, and we'll get our answer. So hopefully you enjoyed, and I'll see